guys, welcome to my YouTube channel. In this video we are gonna learn about how to find derivatives of some standard functions. It is just a quick overlook video where we will see how to apply each formulas. So let's start. So first is the type 1 functions where let f of x is x to the power n. Here f is a function of x only. Now to find derivative of this function, it is given as d of f of x by dx, that is derivative of x to the power n with respect to x, which is given by nx n minus 1. All you have to do is to check what is the form of this x to the power n. Okay, if you can find what is the value of n, then you can find the derivative by just simply using the values of n. For example, if I am taking the function f of x as x cube, okay, so what is the value of n here? Here the value of n is 3. So if I want to find the derivative, then this value will be derivative of x cube by dx, that means derivative of x cube with respect to x. So how to find this one? See, what is the value of n? N is equal to 3. So in the derivative formula, in the right hand side, we will use the value here. Okay, so what is the value of n? N value is equal to 3, then x, this one is 3 minus 1, that is 3x square. Okay, so all you have to do is to find what is the value of n. Okay, taking another example, suppose f of x is equal to 1 by x. So see, here the function is not in the form of x to the power n, but we can make it to the form of x to the power n. See, here the x is in place of denominator. So if I will take this x to the numerator part, then it will be equal to x inverse. Okay, so there is a standard format that if suppose any function is in the form of 1 by x to the power n, then if this denominator value I have to take to the numerator value, then the sign will be changed to minus. So this value will be equal to x to the power minus n. Similarly, if a function is there in the numerator part and I want to make it to the denominator part, then I will use the negative sign in the denominator part. Okay, so now I have redefined this function f of x 1 by x, it is equal to x inverse. Now it is in the form of x to the power n. So by comparing, we can see that this n value is equal to 1. So now what will be this derivative? Now the derivative of this x inverse or this 1 by x with respect to x would be nx n minus 1. So what is the value of n? It is minus 1 into x n minus 1. So now this value is minus 1 to the power x minus 2. Okay. Similarly, if the value is in fraction also, the value of n, whatever it may be, n value is always real number. Okay. So if I am taking this value as suppose x to the power 1 by 3 also, then also we can find the derivative using the same formula, which is derivative of x to the power n with respect to x is equal to nx n minus 1. So let's find out this one. It would be dy by dx, which is derivative of x to the power 1 by 3 by dx. So now see what is the value of n here. Now here n is equal to 1 by 3. So according to the formula, it will be n x n minus 1. Everywhere we are using the same formula. It is derivative of x to the power n with respect to x as nx n minus 1. So now just find out this value. It is 1 by 3 minus 1. So it is 3 into 1, 3. So 1 minus 3, it will be minus 2 by 3. Okay. So moving on to the next section, we'll see another type of function which is in the form of c x to the power n, where c is also any constant. Okay. So how to find derivative here? Here, while finding the derivative, the role of constant is nothing here. Okay. So while finding the derivative, we will just put it outside of the derivative. Okay. So suppose this is derivative of c x to the power n by dx. So I will take this c out of the derivative. So it would be c derivative of x to the power n by dx. So this value is equal to c into n x n minus 1. So let's solve some problems. Suppose I want to find derivative of minus 2 by 3 into x to the power 1 by 3. Okay. So let's compare these values here. Okay. So derivative of y with respect to dx, it would be d by dx of minus 2 by 3 into x to the power 1 by 3. Now see, it is of the form c into x to the power n. Okay. So this c constant will go outside of the derivative. Okay. So let's take it outside. Now this derivative is of x to the power 1 by 3. Now here the value of n is equal to 1 by 3. So the derivative value will be n x n minus 1. Okay. So what is the formula? It is n x n minus 1. Okay. So let's solve furthermore. It is minus 2 by 9. Now this value is minus 2 by 3. So let's try another problem. Suppose I am writing the function as 1 by root 2 x to the power, suppose 1 by 2. Okay. So now let's find the dy by dx. Then here it is d by dx of 1 by root 2 into x to the power half. Okay, so here the constant is again 1 by root 2. So this constant will go outside of the derivative. So now this value would be equal to 1 by root 2 into d by dx of x to the power half. So now this value is equal to, see here n value is half. Okay, so n comes from x to the power n. So the derivative would be half x half minus 1. That is derivative of x n by dx. It is n x n minus 1. Okay. So on simplifying, it would be 2 root 2. Now this value is x to the power minus half. So next move on to other derivative formulas, which are quite easy to find though. We will see what are the other derivatives. Suppose we will take the derivative of sine ax, suppose. Then what will be the derivative? It would be dy by dx, which is sine ax. That means it would be a cos ax. So actually it is a type of function of function. We will see this one later case. After some time I will share the other formulas to find the derivatives. Now we will see how to find derivatives of composite functions, that is using the chain rule. So what is the chain rule? It states that if suppose I am taking a function h as f of g of x, then see here the h function is f of g of x, means function of function. So while finding derivative of h of x, I have to use the chain rule. And how to use this one? So for that, this procedure is to be followed, which is first we will find derivative of f g of x by derivative of g of x into derivative of g of x with respect to x. So now see what I have done. Here I have found first derivative of f with respect to g of x, then into derivative of g of x with respect to x. So what is this value again? So this value will be f dash of g of x into this value will be g dash x. So let's solve some problems. Okay, suppose I want to find derivative of y log sine x. So by comparing we can see that this is a function of function, y is function of x, where here the f function is log and the g function is sine. Okay, so while finding the derivative, I can find this as derivative of log sine x by derivative of x. So using the chain rule, which is stated here, if we will write it like this, then it will be log sine x by d sine x into d sine x by dx. So now see what is the derivative of log sine x with respect to sine x. It would be 1 by sine x into derivative of sine x with respect to x. It would be cos x. So now this value would be cot x. Similarly, let's take another example. Suppose I want to find derivative of sine x cube. Okay, see here there are no separate f and g function, but see we know the derivative of sine x, which is cos x. Okay, but instead of sine x, here this value is x cube. For that reason it is a composite function. Okay, so to solve this problem, we will solve this as, suppose this is sine x cube with respect to x, then see this x cube function is different one, so I will take derivative with respect to this x cube. Okay, it is dx cube. Now this value is dx cube by dx. From this we can see derivative of sine, it would be cos x cube into derivative of x cube, it would be 3x square. Similarly, let us take another formula. If you are finding difficult to use this one, then let's suppose take a simple trick to find this derivative. Suppose I am taking the derivative again. Suppose I have taken sine 2x. Okay, so you just consider this 2x as t. Okay, so in rough space you will solve this as this. Suppose first you want to find this derivative, so let's think this function as sine t. Okay, so what is the derivative of sine t? Sine t derivative is cos t. Then what is the value of t? T value is 2x. So find derivative of this 2x. So it would be 2x. Okay, then simply just multiply these two things. Okay, so let's sum up these two steps and use this formula to find. Then dy by dx, it is d by dx of sine 2x. Okay, so I am treating this function as t. So what will be the derivative of sine t? So sine t derivative with respect to t, it would be cos t. Okay, so instead of writing t, I will write 2x, then into the second step. What is the t value? T value is 2x, so derivative of 2x, which would be 2. Okay, sorry, mistakenly written here, it is 2. Okay, suppose take another example. That suppose y equal to sine x 4 by 2, suppose. Then see how to find the derivative. So first write down the expression. It is sine x4 by 2. Okay, so now treat this function as t. Okay, then derivative of sine t, it would be cos t. Now in place of t, we will write the value as cos x4 by 2. So the first step is sine derivative, which is cos x4 by 2. Then again the second step is inside function's derivative with respect to x. So here 1 by 2 is constant, then x4 has the derivative 4x cube. On solving this is 2x cube. So into derivative of t, that is 2x cube, means first function into the second function. And if we see the algebraic properties of derivative, as you all know already, so still also I am writing this one, the algebraic properties, as it is a quick overview video, so I am not wasting your time. So bus only 2 minutes. This algebraic properties formulas are derivative of f plus g of x whole derivative, it is equal to f dash x plus g dash x, and the second formula is f into z, where both are function of x. Okay, it is also function of x, it is also function of x. then the derivative would be f into derivative of g plus f derivative into g. Then another one, f of x by g of x, the derivative where this g of x is not equal to 0, then it would be g into f derivative minus f into u derivative by g of x whole square. I have said more problems on these basic formulas to find the derivatives here now. Thanks for watching. Don't forget to like and share and subscribe.